A little bit about myself. I was a UCI student like you. I was a transfer student, so if you're a transfer student, your first quarter is going to be rough. If you want somebody's shoulder to cry on, you can come talk to me. So it was a really difficult transition. I remember coming here. I had 4 difficult classes. I had all my general ed were gone. I had 4 difficult classes. I walked around and I'm like, why are all these people smiling? This is terrible. I can't take it. But after 1 quarter, you just adjust. So I transferred to UCI. I was kind of like thinking, I was a biochem double major. I was kind of thinking, maybe med school, but I don't know that I was really serious about it because what I really wanted was to have children, be able to be home with them. I didn't want them in daycare, so probably an MD would not be a good idea. But I was still a bio major, and then I took organic chemistry, and I just absolutely loved it. I loved organic chemistry and decided that I was going to do research, loved research, and so I went off to, I went to MIT for grad school, and super happy. Came back here, took a few years off to have my kids, and came back here and taught as a lecturer. I've been here ever since, so this is really, and this is the greatest job ever, honestly. So that's my background, and let's move on, okay? Questions before we do a little bit more on the syllabus. Anybody? So I have a handout that we passed out, and that's just to give me a little bit idea about you. And you can fill it out today and turn it in, or you can bring it in on Monday. So it's going to give me a little bit of idea of where you're coming from, what are your hopes for this class, and how I can help you do well in this class. Okay, so we've got 3 TAs. Do you guys want to stand up so we can see? We have Taylor, we have Tristan, and we have Alexa somewhere in here. Oh, we're in the back. They're standing in the back. I guess they don't have a seat. We'll have to get you guys the seats, okay? So we are going to be dividing up the discussion sections. I do 2 discussion sections. I have them marked with an asterisk. We'll talk about that. I'll show you where that is in a few minutes. And my 2 discussions are in this active learning classroom. That's where all of the bells and whistles are in that classroom. So we're going to do some fun stuff in there too. We do sapling homework. Now, the way I do sapling, I don't like to micromanage you guys. I basically have 1 sapling assignment for each chapter. So there's a sapling assignment. That sapling assignment is due 2 days after we finish lecturing on that chapter, okay? There are a lot of people that wait until the last minute. They're long assignments because they're meant to span 2 or 3 weeks, okay? And so if you wait till the last minute, you're probably not going to get it done. What we found with sapling is that you get a certain amount of points for sapling, but the sapling does have a profound effect on your grade for the class, okay? So there are some people who go on like half an hour before it's due and suddenly produce all the answers in half an hour. That would be impossible to do. You're wasting your time if you do that. Where you're going to get the benefit from sapling is if you're actually working through the problems, okay? There are answers out there, but it's not going to do you any good if you just go and get the answers. So it's really valuable resource for you. But again, I'm not going to have it due every 3 days, little assignments here, little assignments there, okay? We are doing active learning. This is not a flipped class. We are going to be doing active learning once. Right now, my class is getting filmed for the first 3 lectures. I'm going to be doing a limited active learning for those first 3 lectures because we need to get to a certain point. So my class is on Open Chem, which is available to people all over the world. So there's people all over the world that watch my class. I get thank yous from all these exotic places and people thanking me. The first lecture is missing. The second lecture, you can't even see it during the first half. It was back in the old days when I used to use an overhead projector. And so we had the screen on and we had the overhead projector. You couldn't see anything. So we're refilming the first 3 classes. After that, I do plan on having active learning certainly every single day, but especially on Friday. So next Friday, we'll be all done with our filming. We're going to be doing a lot of drawing resonance structures, drawing hybrid structures, ranking resonance structures, all of that kind of stuff, okay? And so we're going to practice that. What I like to do with some of the active learning is I like to take problems from previous midterms. So I'll be taking problems from last fall's midterm. We'll be working in them in class. So I don't post an old midterm. I'd rather take those problems and work them in class. Okay, so that's going to help you more. We will do iClickers. That's going to happen next week. I don't have anything set up, and so I'll talk more about that on Monday. So nothing you need to worry about in 0 week. And let's see what we have here. All right, so I sent you an email about the textbook, 3rd, 4th, 5th edition. If there is an online, people don't tend to like the online as much, but if you're interested in the online, I can try to find the link for that. I think it's $45 or something like that to have the online, but I think you can actually, if you get a 3rd edition, you can actually get it cheaper than that. So, and the molecular models you're going to need in the 5th week. So when you take your 2nd midterm, you'll be able to bring molecular models with you. So if you don't have them, you're not going to be able to bring them with you. Okay. The ChemDraw link is not working. I'm going to work on that. Something's wrong with that. All right, so I have homework assignments from each chapter. I have them listed for the 3rd, the 4th, and the 5th edition. So what you want to do, and ideally, I mean, I would say this, and maybe my department tutors can correct me on this or not. I would say that if you want to get an A in the class, that you should do sapling and you should do problems from the end of the chapter. Okay, that's going to help you do well. I think it's very hard to get an A in the class if you just do sapling. Okay, so that's what I hear. If you find that that's not true, please let me know, because I don't want to pass around misinformation. That's just kind of my feeling about that. All right. So I did make one really big mistake. In your notes, you've all picked up the notes. We changed one of the chapters this quarter, and so I don't have it in there. And I feel bad about that because it was too late for me to do anything about it. So what you'll find is when you get to the end of your book, there's chapter 7. Chapter 7's in 51B. I apologize that you had to pay like 4 cents a page for that chapter. And so what we're going to be doing is chapter 14 instead, NMR spectroscopy. And when we get to that point, I will post a PDF of that chapter online for you. Okay? All right. We have 2 midterms and a final. We are also going to have participation points for things that we do in class. I take all of those points and I add them up together. I add up the sapling. The sapling ends up being about between 40 and 45 points towards your grade for all of sapling. So I get some people that are very upset. They miss half of sapling, and sapling will give you your score out of 100. It is not 100. It's about 45 points for the entire quarter of sapling. So, you know, if you miss certain points here, certain points there, I will tell you that 95% of the students in this class will get 44 or 45 points on sapling. People tend to get really high grades. So that actual score doesn't really help you as much as the working the problems helps you, okay? Because everybody, you could say that everybody gets an A in sapling, okay? So that's not going to really move your grade up when we do grades in the end. All right, I'm going to let you read through this. We have the exam scanned. If you're new here, we have exams scanned. When we grade on Friday, and we get done with grading on Friday. So we grade all in one day. I don't know with you guys, let's take a little vote here. Do you guys want your grades Friday night? Let's see who says yes. Who wants them Sunday night? You want them Friday night, okay. All right. You know, you don't have to look, right? You don't have to look, I suppose. Okay, so also they're in this transition from EEE to Canvas. I've had so many problems with Canvas, so I haven't really decided whether I'm going to load grades into EEE or into Canvas. We'll see. Okay, I don't even know because we're going to do iClicker through Canvas. I just had so many problems with it this summer. So I'm hesitant to do that. I know that EEE works. So you will get those grades. And then we usually bring the exams, because we grade, it's after 5 by the time we finish. We bring the exams on Monday. We usually get the file back on Thursday night, like 5 or 6 at night. As soon as I get that file back, I post it into the Dropbox. Okay, I know Canvas has a Dropbox. I'm just not doing it. I'm just not doing it. Too close to my bad memories from the summer. Put it in the Dropbox, and then you can print it out. If you have a regrade, if there's a mistake, we make mistakes. You can't grade 400 problems and not make mistakes. By the way, when we grade, person A grades problem number 1 for every single person in the room. Person B grades problem 2 for every single person in the room. That's the way that grading is made more fair. But you are spending 4 hours grading one problem, and so you do make mistakes, okay? So when you make a mistake, you print out your exam, the offending page, you put your name and ID, you write what the problem is, and you give it to me, okay? Don't send it by email. Those are really large files. Those 400, they're scanned in color, they're really large files. Every time I open up an email that has one, it goes to my desktop. I just don't feel like doing that. So you're going to do that, and don't do it by email, okay? Discussion sections. I am doing the 2 that are marked with an asterisk. So the Wednesday at 11 and the Friday at 1 are my discussions. You can come to whatever discussion you want. You can come to all of them if you want, okay? No one's going to do that, but you can come to all of them if you want. So, and on test week, the Friday discussions, well, the 9 will be there, but the Friday at 1 will not be there, okay? That's my discussion. So that means that if you have Friday at 1, you want to go to an earlier discussion that week, whatever one you want, okay? I do have a question for you about the Thursday 8 a.m. discussion. Historically, no one's in my class ever wants to go to an 8 a.m. discussion. Is there anybody who that's the only discussion they can go to? See any hands? Okay, so that discussion is now officially gone away. We're not having the Thursday 8 a.m. discussion. So just so you know, my son followed in my footsteps. He came to UCI as a bio major. He wanted to major in neurobio. And when he was 10, he wanted to major in neurobio. And I said, well, you know, and he also wanted to go to UCI. And I said, well, you know, if you take bio at UCI, once you have organic chemistry, you're not going to want to be a bio major anymore. And he's like, no, I won't. No, I didn't. You know, and so I'm just like, okay, I'm going to shut up and just let this unfold. And it exactly happened. He came in as a bio major, took organic chemistry. He was in my class. I had to get special permission. He was in my class. He never saw exams. I'm super honest. And he did really well. And then he decided that, again, he wanted to be a chemistry major. So now he's at MIT in the same group that I was in, with the same advisor, like literally following in my footsteps. But a few fun things about MIT. For the undergrads, no classes are allowed to start until noon, because they know that most people that are your age, you know, towards the end of adolescence, don't do well early in the morning. No classes are allowed to start till noon. Grades do not count your first year at all. When you grade exams, you're not allowed to use a red pen. Any other color but red, you can't use a red pen because that makes students upset. So, just saying. Anyway. Okay. So now you guys are going to request that we don't use red pens when we grade, right? Okay, so we've got department tutoring, we've got LARC tutoring, and there's room in LARC tutoring if you want to sign up for LARC tutoring. So I just wanted to let you know they're going to be coming in and introducing themselves next week. Okay, how to succeed. Wow, that's the big thing, right? If you treat this class like a math class, okay, and like I would say a cross between a math class and a language class. And you know that if you take languages, they usually like you to come in 4 or 5 days a week because you just need a little bit every day. So it's kind of like that. And it's like a math class in that Completely different than in bio. In bio, you have to memorize a bunch of facts. In OChem, you do, but not the same way. It's more of a problem-solving subject, okay? So in a bio class, if you want to memorize, one of the things you might do is copy over your notes or read the book several times. You don't want to do that in here. You want to be working problems. You want to spend 90% of your time working problems. Like you wouldn't think about, in a math class, you wouldn't think about, oh, I'm just going to go home and I'm going to copy over my math notes 3 times. You would never do that, right? So that's the way you want to handle this class. I have a student who, from a few years back, and she heard me say that. A lot of people hear me say that, but they don't really, I'm not going to listen to that. And so she was really upset because she got 49 on her first midterm. And she came to my office and said, what do I do? How am I going to get better in this class? What am I going to do? And I said, well, show me what you did. And she said, well, look, here's my notes. Here's my notes. I copied them over like 3 times, and I thought I knew the material all really well. And I said, well, take the amount of time that you spent copying those notes over, and work problems, okay? And she did, and her second midterm was a 94. She went from a 49 to a 94 by just working problems, okay? So, I really mean it. I'll remind you of that a few times. Then there's this reference here about what makes a student successful in organic chemistry, and a study was done, and what they found was that the students who start on day 1 and start getting involved in the class, start working problems. When they have something they don't understand, they come and get help. They ask one of the TAs, they ask the professor, maybe the department tutors could help you with it. Those are the people that end up doing really well in OChem, okay? Those are the people that end up doing well. The ones who kind of delay a little bit, maybe you need a little adrenaline to get yourself going. Those people who delay and they don't start right away, and then they start to get like stressed out when it's midterm week and, oh, now I'm going to start studying. Those students do not do well. And those students actually end up spending more time studying than the ones who get an A in the class, okay? So the important thing is that you start right away. We also notice, so I'm doing a study on Chem 51A, the class that I do, and we did a study, and I actually presented this summer at a research conference, and what we found is that the students who did really well in 51A are the ones that when they did 51P, they started right away. Okay, you can see completely different curves from people who didn't do as well. They also completed it. They also did sapling. They also did all of that. So we found it was very illuminating, basically saying the same thing that this study does. Okay. So we don't want you frantically pulling out your hair midterm week because you've gotten behind. So, okay, I would say that's something to take a look at. Best thing you could do, read the chapter. So the article is right here, and I just took some quotes from it. Read the chapter before coming to lecture. Work the problems throughout the chapters as you're reading it, and all of additional assigned problems, okay, at the end. The more problems that you do. And do you do sapling first or do you do problems first? It depends on your style, okay? I don't remember. I think my son did sapling first and then worked problems at the end of the chapter. Okay. Let's see, where's my curve of forgetting? Somewhere in here? It's on the very bottom? Oh, there we go, curve of forgetting, thank you. All right, curve of forgetting. Okay, I really like this curve, okay? So this is basically talking about how you come in on day 1 and this is, and you remember everything I've talked about, you leave this classroom and then you go to sleep, and you can see on day 2 what you remember from what I talked about, okay? So when you're sleeping, your body's deciding, what am I going to put into long-term memory and what am I going to not? I'm looking for my pointer. It's in here somewhere. Somewhere in here. Oh, here it is. So I got this cool little green laser pointer. Let's see if it's going to work here. Okay, here's day 1. That's how much you remember. So while you sleep, your brain decides what it's going to remember, okay? But you actually need that information, okay? But if you just take 10 minutes on day 2 and you read it, look over that information, or in this case, you work a couple problems that deal with that information, that's how much you're going to remember, okay? And then, the next time you do it, 5 minutes, 2 to 4 minutes, okay? So that's just one lecture, but every time you come in here, you get another lecture. So you got to be continually doing this. And day 30, that's when we have a midterm. You don't want to have to relearn all material that we did for 30 days. You don't want to do that. So by doing a little bit each day, it makes it easier for you, okay? So just wanted to show you that. Okay. No, I want to go back to that. I just closed it. Okay. Anyway, letters of recommendation. So I'm going to see a bunch of you a couple of years from now when you decide you want to go to dental school, medical school, pharmacy. And if you want to come ask me for a letter of recommendation, there's a little section at the very bottom that talks about what you need to do. Okay? Questions. Do you have any questions about me? Anything? I was not, yeah, go ahead.
Where are you from?
Mostly from California. We moved to California when I was 7. My dad was in the service before then, so I have a lot of places, but I'm mostly from California. Any other questions? Yeah, over here.
Are the exams in the form of scantrons?
There's no scantrons, no. Yeah, that's why we have a team that grades. If I had to grade all the exams myself, I would have to sit on a desk for an entire week without doing anything but grade exams. So yeah, no, it's not Scantron. We can't really do the Scantron. Any other questions?
Yeah.
Yeah.
Do you want our names or student ID on this, or will it be anonymous?
Oh, it's anonymous. Yeah, no, I don't want your name or ID on that. Yeah. Over here?
What was it about OChem that made you want to pursue it?
Organic synthesis. I just love it so much. Yeah. It's so, I just love it. Yeah.
Is it class curved or?
It is curved. Yes, it is curved. But it's not a standard curve. It's a better curve than a standard curve. So, yeah. I mean, let's just say, for instance, it won't happen, but let's just say, for instance, let's just say, I've been teaching a long time. I know how difficult an exam is. I know if an exam is a reasonable exam, And let's just say everyone in the class got 80 or 90 on that midterm. There's nobody getting a D or an F or even a C on that. You understand? So if the curve is adjusted based on how strong the class is. Okay? So if it's a really strong class, then I will give more A's and B's. Okay? And a standard curve, nobody has a standard curve. A standard curve is 15% A's, 15% F's, 20% B's, 20% D's, and then C's are in the middle, and that's the largest. That's a real curve, so we don't use a real curve. Typically, like this class, the mean will be like a B minus C plus-ish in that range. Okay? More questions? By the way, when I took OChem, I was not the top student in the class. I wasn't. Some of our department tutors did better than I did in OChem. I got A's, but I worked really, really hard, and I didn't have anybody to help me. I was the first in my family to do chemistry, and so I had nobody to help me. My son, gosh, he lives with somebody who could ask him a question. He would never ask me questions, though. He did not want to ask me questions. He wanted to do it himself. So, yeah, I don't think you really had an advantage in that way. Yeah?
How long have you been teaching here?
24-ish years, 23, 24 years. Yeah. So, yeah, I know. Yeah. So I know difficulty level of a test, when I give it to you guys. All right, more questions? Shall we get started doing some chemistry? Yeah? Okay. Let's see if that works. So by the way, this is not a good position for your back. Next time I come here, I'm going to have something to lift this up for me. So, because I will be in a wheelchair and a back brace before too long if I continue to do this. Anyway, I just wanted to show you some. Here we talk about the chemistry of compounds that contain carbon, and so that's like greater than 95% of all chemical compounds are organic. So a super important topic to talk about. I'm showing you some examples of naturally occurring molecules. You're not memorizing these. Please do not memorize these. Those are just to give you some examples. And so we have some little shortcuts that we're going to be talking about very shortly when you write structures. So we're leaving some carbons out here. We're leaving some things out here. But this is right here. This is capsaicin. I have birds in my backyard, and if you give them bird seed that's covered in capsaicin, you don't get rats and you don't get squirrels, because birds can't taste the capsaicin, but the rats and the squirrels don't like it. So that's capsaicin. This is oxytocin, very large molecule. This is sucrose, or table sugar. And this is morphine. Okay, so as you know, we have a painkiller crisis, epidemic of addiction to painkillers. So that's morphine and some of the other compounds. We'll be talking about those coming up in the third quarter. Some variations on morphine. Okay, and this molecule right here is so large. It is 517 amino acids. So we can't draw out all those amino acids, so you see things written as ribbons. This is ALDH2, aldehyde dehydrogenase 2, and about 36% of East Asians have a deficiency in this enzyme. So have you ever heard of Asian flush when you drink alcohol? Okay. So if you get Asian flush, you shouldn't drink alcohol, honestly. If you do, you're at a higher risk for esophageal and stomach cancer. And those are not good cancers to have because there's only like a 15% survival rate for 5 years with esophageal cancer. They are, though, not to make you really depressed and like, oh, no, I can't go on without my alcohol. They are working on things that you can take that alleviate this problem. So things that you can take when you drink so that you still can drink, because you're accumulating acetaldehyde in your brain when you drink alcohol, okay? So it's not working efficiently. All right. I'm going to have to figure out how to get this to scroll better. Okay. Let's go up. Again. All right, synthetic organic molecules, rubbers, dyes, pesticides, rayon, nylon, drugs. This is crystal violet. And there's a picture of crystal violet. And if you have the Majors Honors Lab, we make crystal violet. It's a really cool lab. This is polystyrene. Again, we're using some shortcuts when we're writing these molecules, and we'll be talking about those next week. This is DDT. And sometimes, for some reason, I'm going to work on this file, but sometimes these are all drawn on a Mac, and sometimes when I go here, we're missing bonds. That should not be missing on your page. And then this is Lipitor. Okay, so lots of drugs, very important. Used to treat high cholesterol. All right. Structure determines reactivity. That's the key. So we're going to spend a huge amount of time talking about structure, everything that you ever needed to know about these structures. And then we're going to, once we know everything about structure, we're going to be using that to determine reactivity. Okay, so that's something that's really different about OChem than GChem. In GChem, you never had to really predict reactivity. Maybe if you were looking at oxidation reduction, you could figure out which way the reaction would be favored or something like that. But we're actually doing predicting reactions here. So we have to spend a long time learning about structure. And so really the way this class works is the first quarter, we build the foundation. We spend the whole entire time building the foundation. And then we get into second quarter, and now we're going to start building this really tall building. And everything builds upon everything. So it's like we're going to build the first floor first, and then the second, and then the second, and then the second. So if you have a shaky foundation, that building is not going to stand, okay? So I feel like I do a really good job of giving students a good foundation. And if I give you a good foundation, then, you know, you may decide you want to go to another class. That's fine. You'll have a good foundation to do well, okay? So that's what I do. But it kind of reminded me of last year when they were building the student housing, and like it seemed like for a long time they're moving around the dirt and moving around the dirt, like working on the foundation. And as soon as they get that foundation done, then you start seeing the building go up really fast, and that's a really good analogy. That building does go up really fast, okay? So we're just going to work on building a good foundation. So the other thing is I assume nothing. I assume no previous knowledge, honestly. I start from the beginning. There's a lot of people who will skip chapter 1 entirely and just move on, okay? There's a lot in chapter 1 that you need to know. Everybody's coming in here with a different background. That's why I started that 51P class, to kind of even the playing field a little bit. But not everybody here has taken that class, and so I'm not going to assume that you know what I taught in that class, because some people couldn't do it, okay? So I'm going to start off. You're probably going to roll in your heads, but just enjoy it. Enjoy when you know everything, because it will not last for long, okay? So just enjoy it. And the reason I talk about this at all on this first page is because we do talk about isotopes. And if I don't talk about this, people don't know what I'm talking about when I talk about isotopes, okay? So all matter is composed of the same building blocks called atoms. Oh my, this is where we roll our eyes. So an atom's very, very dense. Like, this is beyond our comprehension how dense. And so I like this fun fact. If the nucleus was the size of a ping pong ball, it would have a mass of 2.5 billion tons. That's how dense it is. And the electrons would be on average a mile away, so very far away. That's it. So the mass of the proton is approximately 1 atomic mass unit. The mass of a neutron is approximately 1 atomic mass unit. And the mass of electron is approximately very, very small, 0.1234 zeros, 0.00005 AMUs. And the atomic number gives the number of protons in the nucleus, and the mass number gives the sum of the protons and the neutrons. So let's look at carbon, our favorite atom here. Atomic number 6, and the mass number is 12.011. Okay, so that means in our nucleus we have 6 protons. The atomic number tells us that. The neutrons are going to vary. If the mass is 12, that means that we have 6 neutrons. And then we also have, so that's our nucleus. We also have 6 electrons outside the nucleus. Okay, and here's where we get to isotopes. Why does carbon have an uneven mass number? If the mass of a proton is about 1, the mass of a neutron is about 1, why are we at 12.011? And that's because carbon, naturally occurring carbon, has isotopes. So we have carbon 12. So when I write the mass number, I'm writing it up and to the left, okay? That tells you that I have a carbon 12 nucleus. Then that would be 6 protons, 6 neutrons. That's the one we just talked about. 6 protons, 6 neutrons. And that's in the natural sample. We would have 98.8% carbon 12. You're not memorizing these numbers, okay? Carbon 13. At the end of this quarter, we're going to talk about carbon 13 NMR, so you kind of need to know what that means. We have 6 protons. The protons don't change, the neutrons change. We have 7 neutrons. And those 7 and 6 adds up to 13, so that's our nucleus. And that's 1.11%. There's also a little bit of carbon-14. 6 protons, 8 neutrons. And this is a trace. There's an actual number for this. I don't know what that number is, but there's a trace of that. And so this is also unstable. It's an unstable nucleus. Therefore, it's radioactive. It has a very long half-life. It has a half-life of 5,730 years. So if you have a natural sample of carbon and you take, let's say you cut down a tree, that tree is going to have a certain fixed percentage of carbon-14. That number is not going to change, okay? But while the plant is alive, but as soon as it's dead, that's going to be radioactive. It's going to lose some of that carbon-14, and that's how we use to date artifacts. So used to date artifacts. All right. So I'm not going to go into that, but that's how carbon-14 is used to date artifacts, if you're interested in that. If you have a pot from a site and it has half the number of carbon-14 than something that's just been made, that means that it is 5,730 years old. So it's just, that's basically what the idea is. Questions so far? All right, so another thing that's really different about this than GChem is that in GChem, when you were drawing Lewis structures and you had a charge, you would take the brackets and you put the charge outside of the brackets, okay? When we're drawing Lewis structures. We don't do that. We don't do the brackets and the charge outside the brackets. We put the charges on the actual atom that it belongs to. And if there's more than one charge, if there's a neutral atom but you have a positive charge and a negative charge, we want the charge on that atom. We need to know where that charge is. Again, because we're in the business of being able to predict reactivity, and that actually helps us to predict reactivity. So let's look at sodium. If you have Na+, okay, common way to find sodium, it's number 11, atomic number 11. So we have 11 protons. It's about 23, so that means the major isotope, we have about 12 neutrons, and we have 10 electrons. Okay, we've lost an electron, so we only have 10 electrons, and we have an overall positive charge. Cl minus, also very common way to find sodium. And by the way, I do put circles around my charges, usually, and that's because, well, we'll see coming on. You're not required to, but I do put circles around it. So Cl minus 17 protons. We know that because it's atomic number 17. We have 18 neutrons, 18 electrons. So we have one extra electron, so therefore we have a negative charge. Okay, so far so good. Any questions? Again, we're starting at the beginning here. Yes? Excuse me?
Is it 10 electrons or
Well, neutral sodium, is it right here? Is this you had a question on? Oh, no, I didn't. I'm sorry. Yes, thank you. Awesome. Okay. Any other questions? I like it when you guys catch my mistakes, because otherwise I'll get a bunch of emails about it. Better to straighten it out here. All right, let's look at bonding. Bonding is joining of two atoms. Through bonding, atoms achieve a complete octet. Outer shell of valence electrons, okay? The octet rule, atoms transfer or share electrons to such a way to obtain a filled shell, okay? So the atoms are happy when they have a filled shell. So they're going to do a lot of different things to try to obtain a filled shell. So for hydrogen, a filled valence shell is 2 electrons. for a filled valence shell. So that's actually not the octet rule, it's the duet rule, but you know, we're not going to worry too much about that. Hydrogen's happy when it has 2 electrons in its valence shell. And second row elements, which is 95% of what we do in this class is second row elements, okay? So that's going to be 8 electrons for a filled valence shell. Okay, and so when we have something in the second row that has a filled valence shell, it's going to have neon configuration. And hydrogen, when it has a filled shell, has a helium configuration. All right, so there's 2 ways that atoms can interact to obtain, so these are both noble gases. A filled shell is a noble gas configuration, and there's different ways that atoms can attain a noble gas configuration. And so the ionic bonding and covalent bonding. So let's look at both of them. We don't do too much with ionic bonding, but let's talk about it anyway. Atoms attain a filled shell by transferring electrons. So when you have ionic bonds, an electron is completely transferred from one atom to the other. Okay, so for example, we have lithium. Lithium, picked straight off the periodic table, has 1 electron. Fluorine, if you pick that straight off the periodic table, it has 7 electrons. Okay? And so what happens is, we combine the 2, what happens is the lithium is going to donate its electrons to the fluorine. I'm going to use an arrow. We're really big on arrows, okay? I'm using a single-headed arrow. It's called a fishhook arrow because I'm trying to show movement of 1 electron. Most of the time in this class, we're going to use double-headed arrows that show movement of 2 electrons, but this is a fishhook arrow. Fishhook arrow shows movement of 1 electron. All right, so when lithium transfers its electron to fluorine, we get lithium plus and F minus, fluoride ion. So the F minus has the neon configuration. And the lithium has a helium configuration. So noble gas configuration, everyone's happy. And then the actual ionic bond is that electrostatic attraction with the positive and the negative. It's not the transferring the electron. Okay, so held together by electrostatic interaction. Electrostatic interaction in a crystal lattice. All right, so there's the ionic bond for you. We don't do too much with ionic bonding. Most of our stuff is going to be covalent bonding. Ionic bonding is seen when we have atoms with widely differing electronegativities. Okay, widely differing electronegativities. So this is one of the trends that you talked about in GChem, and one of the trends that you're going to need to know, and that's the electronegativity trends. So as we move to the right across any row in the periodic table, we have increasing electronegativity. And as we go up, I'm not going to put this to the right because we really won't see electronegativities for the noble gases. We're just going to go this way, okay? That's also increasing electronegativity. So that means that fluorine is going to be the one that's the most electronegative. Okay? You do not need to memorize these numbers for electronegativity. If you need them, I'll provide them, but I do want you to know the trend. Okay? All right, so if electronegativity is greater than about 1.8, about, because there's some exceptions to this, so we want to say about instead of exactly. The electron's going to be transferred completely and not shared. Okay? So lithium has an electronegativity of 1, and fluorine has electronegativity of 4. The difference is 3. Is 3.0. Therefore, we're going to have an ionic bond. So when we have covalently bond compounds, those are closer in electronegativity, but that's time. We'll stop right there, and we will continue this on Monday. I hope you guys have a fantastic weekend.